Hello, good afternoon, everyone. My name is Pratik, and today we will be talking about Simulia Power of Portfolio and its advantages, as well as later on the promotions, which our sales guys will get back to you. So, coming to Simulia, Simulia is a brand for realistic simulation application. What is Simulia? Simulia is the Dassault Systems brand for realistic simulation. As you can see on the screen, a compass which has 3D, I, V plus R, and social and collaborative apps. So under V plus R, which is nothing but virtual plus realistic, all the simulation apps come under this category on the Simulia compass. Now, what can realistic simulation tell me? Most of the times, how realistic simulation can help anyone is with the help of realistic simulation, you can ask questions like how can I improve my design, how will it perform if it is used off spec, as well as will my product pass the required certification testing, or even you can find about the life, uh, how long a product will survive, etc. So all these questions can be asked and answered through realistic simulation. Now, coming to realistic simulation, what kind of industries use realistic simulation? So almost all the verticals that we know of are using realistic simulation. Some of the examples are transportation, aerospace, heavy industry, biomedical, etc., as you can see on the screen. And the next question would be, which customers use realistic simulation? And to answer that, nearly all Fortune 500 companies and many smaller supplier companies as well as tier 1 companies use realistic simulation. Some of the examples are shown here on the screen, like Dana, Schaeffler, Eni, Boeing, EDM, Becton Dickinson, etc. These are all the companies that are currently using realistic simulation. Now, going more into the details, let us talk about who are the users of realistic simulation. Again, both commercial as well as academic. When it comes to commercial, designers, design engineers, simulation specialists or analysts, as well as researcher use a lot of realistic simulation to validate their tests, and so that they can decrease the product life cycle time, as well as even academic, like educators or researchers from academic field, instructors using simulation as a valuable teaching tool. They make sure that the students are well equipped with all the simulation tools, and scientists who are nothing but academic researchers, specifically employed in the academic sector, and who want to develop new technologies and have wanting a deeper understanding, use realistic simulation. Now, coming to Simulia's power of portfolio, what is power of portfolio? So, power of portfolio, under power of portfolio, we mainly have 4 different softwares, as shown onto the screen again on the left hand side. These 4 softwares are Abacus, which is more physics and open core simulation kind of a software. And with the help of Abacus, we can perform Abacus implicit or standard analysis, as we refer to, can perform Abacus explicit. Then there is coupled Eulerian Lagrangian method, fluid structure interaction method, the SPH method, the electromagnetics method, as well as there is also Abacus CAE, which is used to build a model, be it geometry cleanup, be it meshing, applying boundary conditions and loads, etc. All that can be done through Abacus CAE. Then comes EyeSight. EyeSight is nothing but a process or automation as well as a design optimizer, which is used to run a design of experiments. And EyeSight consists of design gateway, application components, and process drivers. So many of the design of experiments can be carried out through EyeSight, and it uses optimization techniques like Latin Hypercube, Six Sigma, etc. to quickly give results of optimization. Then comes Tosca. Tosca is nothing but a topology optimizer, and it can carry out both structural as well as fluid flow optimization. It also has linear and non-linear optimization capability. For an example, to give an example of Tosca, what Tosca basically does is, I have a baseline model. I feed it to Tosca along with the baseline results. Now, keeping those results as constraints, what Tosca tries to do is it tries to give out or carve out the best design, thereby reducing the weight. Now, this reduction of weight is one of the examples. Now, with the help of Tosca, I can carry out 4 different kinds of optimization. One is topology optimization, which we just spoke about. Sizing optimization, I can check for what the size would fit the best. Shape optimization, in certain cases, because of hotspots or stress accumulation, we need to make a minor shape changes. Instead of reducing material, we simply need to make shape changes, and Tosca helps us to suggest those shape changes. Bead optimization for stiffness, for eigenvalue as well as frequencies and all. Tosca will predict where the beads can be inputted onto your given sheet metal. And then the last software that comes under power of portfolio is FESAFE. It is to predict and analyze the product life. So we can do a low cycle or a high cycle or a mixed cycle fatigue analysis and durability correction. So this all comprises of Simulia's power of portfolio. And again, once again, namely the 4 softwares, which are Abaqus, iSight, Tosca, as well as FESAFE. Now let us have a look at overview of Abaqus. We'll spend a few minutes on each of all these 4 softwares to understand the capabilities. So Simulia's foundation has been Abaqus, and as we all know, it's one of the world's technology leading suite of finite element analysis. And the different types of analysis that can be carried out using Abaqus is linear and non-linear, implicit as well as explicit dynamics, contacts, which is one of the stronghold or the strong point of Abaqus, certain types of fracture analysis, decomposites analysis, as well as co-simulation like thermal, structural, etc. All these kind of sophisticated analysis can be carried out through Abaqus. And as I say, it's one of the world's leading. It's also one tool for all. So any kind of simulation, be it a dynamic, crash analysis or hydroplaning of tires or structural analysis, all that these can be carried out using Abaqus. Some of the examples are shown on the screen right now. Now, as I said, Abaqus products is made up of two branches. One is the solver, which you can see the first point, that is the standard or implicit and the explicit solver. So this is mostly for non-linear engineering capabilities. And of course, these solutions are all designed for production use. All the results have already been validated, and hence I can directly use it for a production use. And then comes the Abaqus CAE. It's a complete environment for pre-processing as well as post-processing of Abaqus analysis. Abaqus CAE is a preprocessor wherein I can build pretty much simple to moderately complex parts. I can do basic CAD cleanup. We can do the meshing, load and boundary condition application through Abaqus CAE. And then we have Abaqus Viewer, which is one of the world's top class, in-class viewer, wherein I can go ahead and check for my results, do hot spot result extraction. We can visualize how a certain component behaves under certain load condition, etc. This is all through the Abaqus CAE as well as the Abaqus Viewer. How does it all fit together? As we can say, this is one of the example of the GUI of Abaqus on my screen. And we have a dedicated SolidWorks as well as a CATIA associative interface, meaning whatever changes I make in SolidWorks can be reflected directly onto your Abaqus GUI. As well as the layout of the GUI is pretty much simple. You can see a small module on the screen. So the module guides the user to set up a model in your Abaqus CAE as well. And this is the viewer. So once the run is complete or once the solution is achieved, I can simply, in the module, as you can see, it has been switched to visualization, wherein I can see how it is, how the load conditions are acting. So this is what is the viewer. Now, also Abaqus provides solutions for entire range of industries, be it consumer packaged goods, life sciences, high tech, energy, etc. Some of the examples again are shown onto the screen. These are the industries that are currently using extensively using Abacus day in and day out. Now, let us talk a little bit on Abacus CAE, what Abacus CAE is, what it comprises of. So it's a modern graphical interface, and like I said previously, it is very well organized and very easy to use and even to learn. And it also has object action paradigm. There is a customizable toolbars as well as a model tree, which makes the job easier to work on. Again, it also has geometry and model import. So either I can import a geometry, or if I already have a mesh model from some other third-party software, I can even import that. And we can create all the way up to simple to moderately complex geometry that can directly be created in Abacus, not through any CAD software, but through the Abacus. And associative CAD interface also preserve analysis attributes when the geometry changes. Meaning, I have made a component in CATIA, then I have already built up the model in Abacus. I run the analysis, and then the analysis suggests to me to make certain changes. So when I make these changes on CAD level in CATIA, all these changes are reflected into the Abacus because of the associativity, and I don't have to recreate the model or the boundary condition as such. It all is been taken care because of the associativity. So that's what it means when I say it preserves analysis attributes. And apart from that, complete set of geometry repair tools, like if I want to do a geometry cleanup, defeature certain features like fillets, washers, etc. If I have to repair certain faces, re-sewing of the surfaces if it is not watertight, etc., can all be done using the set of geometry repair tools. Again, when it comes to meshing, very powerful and flexible meshing algorithms are available in Abacus. It's pretty much fast as well to create automatic free meshing, as well as certain semi-automatic hex meshing is also possible. As well as many different ways to import the features and to mesh them and assign the mesh properties. These are all very easily and quickly accessible tools are available in Abacus CAE. And then coming back to the visualization tool, it's a most preferred visualization result viewer for all the Abacus kind of analysis. It has a very high performance as when we are comparing with respect to the very large models. Very large model result files can easily be imported and viewed, and we have so many different options like transparency, view cuts, probing, plotting, equations, etc., which can all be applied and the results can be extracted. And also customization, powerful extensibility and customization is possible using Abacus. Python scripting is available to automate repetitive tasks so as to cut in time. I can create vertical applications and then drag and drop GUI builder as the way it is required can all be created all through the Abacus CAE. And coming to Abacus analysis products, now as I said, we have two different types of solvers which is available in Abacus. One is implicit and the other is explicit. Now, based on implicit solution, mostly implicit solution techniques are used for static and structural events, linear as well as non-linear behavior. Some of the examples of implicit functions are currently shown on the screen. For example, a clip insertion, be it a seal insertion or a tire noise, gasket sealing, etc., can all be carried out using the implicit solution technique. Now comes the Abacus explicit. Now, again, explicit is a time integration method. This is used for high-speed transient dynamic events like a bottle drop, a crash analysis, or a metal rolling, blast loading, etc. As well as this explicit solution is also used for highly nonlinear quasi-static events. Coming to the solver, Abacus has one of the most robust and accurate non-linear solver. It is designed to handle basically model of any size, be it a small component or be it an assembly of components, or be it a if I speak with respect to automotive industry, a full vehicle level as such. And it's fast solving, because of the algorithms are designed in such a way that it marches to a solution faster. It scales efficiently when using multiple cores. One of the example, as you can see here, is the validation of the side impact for a B pillar. And on the extreme left hand side, you can see the actual test rig wherein the load is applied to the B pillar, and you can see when it snaps out. So similarly, we are validating using Abaqus. So these results are all validated. And also on the right hand side, we can see runtime versus number of cores. So one thing is, as the number of cores increases, the solution time is reduced very much. For example, if I have 2 cores, it takes about 20,000 seconds for an example file to run. Then if it is 16 cores, it takes less than 5,000 seconds. So it also depends on the number of cores that the user would be using. Contact. One of the most robust tool Abaqus has is the contact problems. Any type of contact problems can be very easily solved using Abaqus. And one of the most important capability is the general contact capability, wherein I don't have to go ahead and specify any contact pairs or create any contact pairs. I can, while building up the model, I can simply tell Abaqus to use a general contact capability, wherein when the solution, when it is solving the problem, what happens if a component A is coming in touch with component B, at that time, the elements or the area where contact happens, Abaqus automatically creates or activates contacts in those areas, which is one of the most simple to set up capability that Abaqus is providing. Coming to material models, again, extensive material models can be created. Abaqus doesn't have a material library as such, and for one reason, the user can create extensive models, material models, and that is one of the reasons why Abaqus doesn't have any material library as such. So when it comes to metals, rubbers, and composite, linear, non-linear, elastic, and plastic property material, both isotropic as well as anisotropic materials can be created. Apart from that, additional some of the materials that can be created or included in the Abaqus CAE is soil and rocks, concrete, ceramics, paste, etc. All these kind of materials can very easily be created. Then there is advanced analysis. Also, Abaqus can be used for more sophisticated advanced analysis like natural frequency, including preloading effects. So as you can see on the screen, step 1 stress at 10,000 RPM, step 2 its mode shape at 99,000 Hertz, and mixing both these results is what we are getting the final results. That is what preloading effects are. Similarly, damage as well as fracture, and you can see on the top right corner how we have the crack propagation has been validated between the test results as well as the simulation. So you can see in the test where it is actually the crack is being initiated and where the component fails. Similarly, in simulation, it is exactly the same area where the crack is being initiated. And some other examples are delamination modeling, progressive damage of fiber reinforced composites. So all these kind of more sophisticated and advanced analysis can easily be set up and carried out in Abaqus. Some other examples of advanced analysis again, wherein we are in these examples we are trying to simplify the mechanisms by using rigid and deformable mechanisms. So instead of using the components, we are taking into consideration the rigids and links. Multiphysics analysis, again, thermal stress analysis, as you can see here, the heat generated in a disc brake, or a coupled thermal electrical stress analysis in case of resistance spot welding. All these are some of the few examples that can be carried out in Abaqus. Now, coming back to the summary, Abaqus analysis products is used for realistic simulation for all verticals of industries. It supports both linear as well as non-linear behavior. Sophisticated contact and material modeling can be handled very easily in Abaqus. It has high performance solvers. Coming to Abaqus CAE, very modern, easy to use graphical user interface, and you can integrate it with popular CAD packages, and as well as comprehensive support for Abacus functionality and single solution for all analysis needs, meaning I don't have to keep moving from one solution to another solution to carry out different kinds of solution. Now, let us talk a little bit about FESAFE, what FESAFE is. So this is, as you can see on the screen, the fatigue analysis process. Again, like I said previously, FESAFE is a software for fatigue analysis as well as to predict the life of a given component. So it starts all with the designer. The designer creates the design which is sent to the analyst for FE analysis, be it Abacus, Nastran, or ideas, etc. If there are any changes, the analyst again tells it to the designer redesigns it, then and he reruns the analysis. Now all the results, like all the stresses and temperature, are taken as an input, and then they are sent to FESAFE along with the duty cycles. And now FESAFE will predict the life counters, like how long or under how many cycles it will go before it fails, etc. This is all the process for FESAFE. Now, coming to FESAFE supported input and outputs, so not necessarily you always have to have a file which is run in Abacus for FESAFE. Any other files, if you have analysis done in ANSYS, ideas, Nastran, Pro, Wildfire, Creo elements, etc. These can all be supported input and outputs for FESAFE, as well as other outputs that are supported by FESAFE are Hypermesh, Patran, FEMView, CADFix, FEMAC. So these are all the supported input and outputs for FESAFE. Now, for example, it is a part of an automotive drive shaft joint, and initially what happens is the first impression when I run the analysis is for an analyst, he thinks that the cracks would start from the maximum stress location. But actually, when you run it through the FESAFE or the fatigue software, we come to know that cracks did not start from the maximum stress location. And this was corroborated or validated by the lab test on actual specimens. So this you can see. Now, some of the examples, like I said again, the effect of overload. So on the extreme left-hand side, in the middle, we can see only high-level fatigue loading. On the extreme left-hand side, we can see only low-level fatigue loading, and we can see where the part is failing. And at the bottom of the screen, you can also see the fatigue, the life cycle that has been predicted by FESAFE, and it exactly predicts the same location where the actual component has failed. When it comes to only high-level fatigue loading, again, we can still corroborate that the part that has failed in the test rig is exactly the same location that the FESAFE is predicting where the part will fail in the simulation world. Now, what if I mix? What if the load factor is a mixture of high well as low level? In that case, we can clearly see the failure location of the component is completely different as compared with the low level fatigue loading only and only high level fatigue loading. And we can not only see that in the test rig, we can also see the software exactly predicting the same location. So this is how much the software has already been validated, and all the results that FESAFE predicts are, highly accurate. Now, a little bit overview of Tosca. So we'll see about what Tosca is, what are the different types of optimization Tosca can help the user. So briefly, previously I had said, there are 4 different types of optimization that Tosca can do. One is the topology optimization, as you can see on the extreme left-hand side. And you can see here, the gray part, the first gray part is what was fed to Tosca along with the initial baseline results. And considering those results as constraint, what Tosca has done is carved out the best design, at the same time saving a lot of material, as you can see. So that is topology optimization. Then the sizing optimization. Now, what Tosca does in sizing optimization is it will help you reduce the mass by optimizing the sheet thickness. So certain times we simply go with the baseline thicknesses, which might add cost. So Tosca will help you to predict a optimized thickness, thereby saving cost. Then shape optimization, like I said, in the first model, which is on the top, you can see there is a stress concentration, which is circled. And similarly, when I fed this model to Tosca and fed the results, it will suggest certain shape changes, be it increasing or decreasing the fillet radius, or or change or increasing the thickness of the rib, etc. And thereby, I can reduce local stresses and increase the durability. And the fourth one is the Tosca bead optimization. This will help increase the stiffness or eigenfrequency of a sheet metal structure, and Tosca will predict where the beads should be applied onto a given sheet metal. So these are the four different types of optimization that can be carried out using Tosca. Again, structural optimization, design process with your FEA solver and Simulia Tosca structure helps you to reduction of the weight. It also enforces desired stiffness. It minimizes the maximum stresses as well. Now, like I said previously, you can see on the right hand of the screen, it's an initial design space geometry. And then what we do is we create a finite element model out of it. Then this is an optimization of the model. We constrain the bolt holes because these are very critical where this component will be bolted. So we constrain it. And then we feed it to Tosca along with the baseline results. So keeping the bolt location and the results as constraints, what Tosca does is it carves out the best design out of the given design space. And that is what we can see currently. So all the red color is the final product, and all the gray product is the material that it has removed, thereby saving me that much amount of material. And then smoothing, again, as you can see, the red color one, the previous one it's a rough cut. So Tosca does a smoothing and it gives us a validation file. Now I take the validation file and I run the analysis, and you can see the stresses are very much low. There are hardly any red spots on the given model. And then we try to do a shape optimization again for it to give us the best design. And this would be the optimized design geometry or the final geometry that can be sent to manufacture. So this is the process for a Tosca structure, basically. Now, another good thing about Power of Portfolio is integration of Simulia Tosca structure in any existing CAE environment. So be it Abaqus CAE we get a model from a CAD system, it goes to a CAE processing, be it Abaqus CAE, ANSYS, ANSA, Hypermesh, Patran, Siemens NX, etc. Then it is being fed to CAE solver, which can be Abaqus, ANSYS, or MSc Nastran again. And it's a fully automatic integration of non-parametric optimization. And then we can send it back to CAE post-processing, and you can use Abaqus viewer to view results, be it ANSYS, be it Meta, FEMAP, etc. So all these can be easily integrated so that you can use Tosca not only with Abaqus, you can use this along with ANSYS, ANSA, FEMAP, Hypermesh, like we have already suggested. And the integration is pretty much simple. There is no complexity involved at all. So this is one of the examples. This was a topology optimization of a transverse link at Audi, and you can see an existing design already. So design space model was created. So basically what we do is we fill in all the features and we make it a space model, as you can see in the red color. And then it was fed to Tosca. It's again the same process that I've previously talked about along with the results. And now Tosca will carve out the best design. And these are the cutting splines. And this is the redesign. So starting from the existing design, we can see the newly designed or the redesigned product adheres to the same given conditions, loading conditions, but at the same time we can see material has been drastically reduced, thereby saving cost. Again, comparison. This is again a comparison. Weight-wise, the graph shows about the dark blue color is the existing design, whereas the green color or the light green color is the new design. As you can see, the weight has been reduced from 100, I'm not sure if it is 100 kgs or 100 pounds to almost 85 pounds or kgs. Similarly, this stress has decreased from 100 to over 58, and displacement as well. And with the help of Tosca, I can speed up the development process. Almost 45% stress reduction in this particular example, 10% weight reduction, and on top of that, the first prototype passed all the mechanical tests. So this is one of the advantages of using Tosca as an optimizer. And now coming to overview of eyesight. Like I said previously, eyesight is nothing but a parametric optimizer used for design of experiments. And we call it as an eyesight software robot, which helps us to a user to automate process. So what basically here happens is, as an engineer, I can define simulation process and design goals, and all these we can automate the input generation, run, and output extraction. So what this means is I can link in, say, in this case, I'm going to talk about Abaqus. I can link in Abaqus uh, to eyesight, and it will be a cycle. So I'll create a design in Abaqus and I'll automate the process. So what eyesight does is, once the model is built in Abaqus, the model will be pulled in eyesight. Then eyesight will run its design of experiments and then feed the new design of experiments back to the Abaqus, wherein Abaqus will build the models and rerun those. This is just an example. And as you can see on the right hand side, I have a design concept. I build a computer model. I choose a strategy, be it Six Sigma, be it Latin Hypercube or Hypercube. Then we adjust the input files, we run the model, we review the output files, and we check if the requirements are met. If the requirements are met, we simply move on to the final design. If not, we rerun this whole process. And eyesight is very much suitable for frequently used application. And if my model has many constraints and many degrees of freedom, and it involves multi-step and sim flows, conditional sim flows, etc., eyesight can be used. To generally talk about eyesight, how the optimization and design exploration work here is, this is an example for design for a Six Sigma, which is for robustness and reliability analysis. I have a certain input, I have a constraint boundary, and I will check for the outputs that lie in the feasible or the safe zone. So many of the times when I carry out this design of experiments, there might be a few designs that will lie in the safe zone or the feasible zone. And then being as a user, I would have to find out the best design out of that zone. So if you see here, once the eyesight has run its algorithm, we can see all the small dots, the red and the green dots, are the number of iterations or the number of design of experiments that has been done, carried out by eyesight. And the red dots are the unreliable designs, whereas the green dots are the reliable designs. Now, out of that, whichever is closer to this constraint boundary, I will be picking it up, because there are so many different constraints, manufacturing constraints, or we have to look at all those and choose out the best design out of it. And that's how I chose the most robust and reliable design. Now, what are the benefits of eyesight? It reduces design time. It has a template for frequently used design processes. You can automate parallel submission of optimization, and algorithms like Monte Carlo, DOA jobs on multiprocessor machine, etc. can be used. I can improve the quality, design to target for simulation attributes. Again, it also helps us to understand my design in a better way. It can also help us to understand what parameters are influencing the design targets. If any parameter is helping the design to be more be better, or is it helping it to fail? All these kind of design understanding can be done through eyesight. Pillars of innovation, again, Simulia's power of portfolio. Quick look back. Simulia's power of portfolio consists of Abaqus, eyesight, Tosca, and FESafe. And this picture gives us a complete picture of integration of these softwares. So I do a physics exploration using Abaqus, and then I do a design automation and design support using eyesight to find out the best design of experiment. Then I do a design exploration using Tosca structure, and as you can see from design automation to design exploration, how Tosca has carved out the best design. Then I do a detailed design study using Tosca structure, shape change, shape optimization, and then finally a virtual sign-off using FESafe to predict the life. So this whole process is being done by using Simulia's power of portfolio, that is Abaqus, eyesight, Tosca, and FESafe. This is how the power of portfolio can help you to come up with the most reliable, robust, and best design quickly, instead of moving from solutions to solutions. Now let us talk about a little bit about token requirement. Because currently what Simulia Power of Portfolio means is you don't have to buy all these four software separately. It is based on token, and the tokens are shared between all these four software. So if tomorrow if you buy n number of tokens, you will not only have Abacus, but you will have Abacus, iSight, Tosca, as well as Effisafe. You don't have to spend extra and buy these software separately. They all come under one platform, and hence we call it as Simulia Power of Portfolio. So again, Abacus CAE is supported by interactive licenses, whereas Solver Jobs use compute tokens. So this is an example of the tokens table, and how many tokens are required for FlexNet. So if I have one core, just to run Abacus, I would require 5 tokens. If I have 2 cores to run Abacus, I would require 2. If I use 4 cores, I would require 8. Actually, this is not linearly. So as the cores increases, the number of tokens starts reducing. So if you see 64 cores or 128 cores, you will see for 64 cores, the number of tokens required is 28. Whereas for 128 cores, number of tokens required is 38. Now, the token requirement for Power of Portfolio. For one single user on one single core, just to use Abacus, a minimum number of 5 tokens is required to open up the Abacus GUI, create the model, and to run the analysis. Whereas if I want to use Effisafe for a single user on a single core, I would require 7 tokens, a minimum of 7 tokens. And for Tosca, a minimum number of 8 tokens is required for a single user on a single core, only for linear. For non-linear Tosca optimization, I would require about 13 tokens. And for iSight, anywhere between 1 to 10, depending upon the type of DOE optimization you are running. But we would usually suggest about 3 tokens. So if I have 5 tokens, I can, at a given point of time, one user on one core can either use Abacus or iSight, because the minimum number of tokens required for iSight are 1 to 10. So if I have 5 tokens, I can either use either of the software at any given point of time. And if I have 13 tokens, I can completely unleash the power of portfolio. I can run Abacus or Effisafe or Tosca, both linear as well as non-linear, or iSight, but one at a time, not simultaneously. So again, this is one of the pictures of how the token system is distributed. So if I have 5 tokens, I can what I'll get in 5 tokens: Abacus Solver or iSight, plus Abacus CAE, iSight gateways, and GUI. If I have 7 tokens, I can either solve for Effisafe Fatigue Engine or Abacus Solvers or iSight, and I'll get Abacus CAE GUI, iSight GUI, Effisafe GUI. If I have 8 tokens, I can either use Tosca structure linear optimization or Abacus or Effisafe, plus I will have Abacus GUI, iSight GUI, as well as Effisafe GUI and Tosca GUI. Whereas when I have 9 tokens, if I have 9 tokens, I can use Tosca Fluid with third-party CFD solver, or I can use a Tosca structure non-linear, but again with a third-party solver, or I can use Tosca structure linear or Effisafe engine or Abacus or iSight. And along with this, obviously, I'm going to have Abacus, iSight, Effisafe GUIs. Whereas when I say 13 tokens unleashes the power of portfolio, with the help of 13 tokens, I can use Tosca structure non-linear with Abacus solver, or Tosca Fluid with third-party CFD software, or Tosca structure with the third-party software, or Tosca structure linear and Abacus foundation, or Effisafe, or Abacus, along with Abacus, iSight, Effisafe, all these GUIs. Now, the benefits, what are the benefits of power of portfolio? First of all, instead of buying these softwares separately, when I buy power of portfolio, it is 2.6 times cheaper as compared to buying these softwares individually. And it is very simple to use. Basically, I have extended GUI licenses, which comprises of Abacus CAE GUI, the iSight Design Gateway GUI, the iSight Runtime Gateway GUI, the Effisafe Interactive GUI, the Tosca interface. And extended tokens are nothing but the solver tokens. And these tokens, solver, can be shared between Abacus Solver or iSight SimFlow or iSight Process Components as well as Tosca Structure, Tosca Fluid, as well as Effisafe Solver. And you can, depending upon your requirement, it can be easily scalable. So if you want to increase the number of cores, or if you want to increase the number of users, you don't have to keep buying the softwares. All you have to do is simply keep on adding the tokens, which will again be cheaper as compared to buying the software as a whole. So that's all from my side, guys. Thank you so much. Any questions? We can take it now. Thank you.